Now in this video we'll be looking at instantaneous acceleration. Okay, so when we talk about instantaneous, we're talking about something happening in an instant. Okay, happening in an instant means at a particular period of time. Like I can find my speed in 1 hour, in 2 hours, in 3 hours, in 4 hours. So at different points is what we call instant. I can also find my acceleration in different period of time. Okay, so that's what we call instantaneous. So in this very question, they said a car position is given by st equal to this. So this x represents position or distance. Okay, when we talk about position, we're talking about distance or displacement. Okay, a car position is given by, so this question can also come out in the form a car displacement is given by, or a car position is given by, or a car distance is given by. You understand? So solution, they made us to know that the car position xt is given by 2t raised to power 4 plus t raised to power 3 plus, okay, minus, that is minus t. Then the unit of distance, we know that the unit of distance is what? Meters. That's why this m is here. So now they say I should find what? Instantaneous acceleration at time t equal to 2 seconds. So let me explain this now. If I have position, this is position x. Position can be x, and again position can be what? Y. Like if we have sy coordinate, this is y coordinate, this is s coordinate. So any distance I cover here is in s coordinate, any distance I cover here is in y coordinate. So this thing can be in form of s, it can be in form of y, it can be in form of anything. But the most important thing is to understand the concept or what it is trying to, give, or the information it is trying to pass. This is telling us that st is the what? Position. So now, and this position depends on what? Time. So since I'm looking for acceleration and I have distance, so look at how it goes. If I have distance and I know that velocity means change in distance with respect to change in what? Time. Okay, I can still write this as change in x over change in what? T. If you check this, this is what? The y dt. Okay, so when you differentiate your position with respect to time, what you get is what we call what? Velocity. So velocity is the rate of change of displacement with respect to time. So the s dt is the same thing as velocity. I know this is a slope. Okay, it's a slope, but it represents velocity. Now, what is acceleration? Acceleration means change in velocity with respect to change in what? Time. Okay, that is change in v with respect to change in t. So if I should differentiate this again, I will not get what? Acceleration. So acceleration simply means differentiate v with respect to t. So this is d dt into, who is v? Who is v? V is what? The s dt. Such a way that when we combine it, we have d squared x over what? dt squared. So this will tell us that if we have a position and we differentiate it once, we get velocity. And if we differentiate that thing again with respect to t, we now get what? Acceleration. So it means that velocity means the s dt, first order differentiation, while acceleration means d squared x over dt squared. So back to what we have. We are given position and we're asked to get what? Instantaneous acceleration. So my concentration is on acceleration. So what I'm going to do is that I will differentiate this once, I will get velocity. Now to get acceleration, I will differentiate it again. Now how do we differentiate? Assuming we say that, let's say x is equal to 5t squared plus 8t. Let's say raised to power 4 for an instance. How do we differentiate this? Differentiation, if I'm differentiating s with respect to t, the rule says use the power of the value of this, multiply by the coefficient, remove 1 from this. So like 2 times 5 will give me what? 10. I will write t. If I remove 1 from 2, it will remain 1. Plus 4 times 8 will give me 32. Okay, then t raised to power 4 minus 1 will give me what? 3. Okay, assuming I have x equal to 2t squared plus 3t for an instance. Okay, so if I'm finding the s dt, remember the rule, this multiplies this. 2 times 2 give me 4. I remove 1 from 2 to remain 1. T raised to power 1 is t, plus the power of this t is 1. 1 times 3 is 3. Then I have t Now, this t has a power 1. 1 minus 1 is what? 0. Any t raised to power 0 will be what? 1. 3 times 1 is 3. So I will leave this like this. Okay. So on that note, let's come to this. So this is our xt is equal to 2t raised to power 4 plus t cube minus sod t. Now, this sod t means power half. Okay. So I can still write it out as 2t to 4 plus t to 3 minus t raised to power 1 over what? 2. So I'm doing it like this to avoid confusion. Okay. So now let us get our velocity, which is equal to change in x over change in what? T. So let us go there. 4 times 2 is what? 8. Then t, we remove 1 from 4, we have what? 3. Plus, the coefficient here is 1. 3 times 1 is 3. T, we remove 1 from 3, we have 2. Then minus, the coefficient here is 1. So half times 1 is half. Then t, then this half minus 1. That half minus 1. It will give us minus 1 over 2. Remember the rule. This times this, you write, you subtract 1. This times this, you write, you subtract 1. This times this, you write, you subtract 1. Okay. Next, this is our velocity. Had it been that they say we should find instantaneous velocity now, we just find this when t is what? 2. We substitute 2 to be 2, 2, 2, 2, 2 all over. But here we're looking for instantaneous acceleration. So we're going to differentiate that thing again. So we're looking for acceleration. We know that acceleration means second order derivative of position. So we're going to differentiate this again. 3 times 8. 3 times 8 should give us 24. Then we have t. When we remove 1 from 3, it will remain 2. Plus 2 times 3 will give us 6. When we remove 1 from 2, it will remain 1. That is t to 1. Now, minus half times minus half will give us plus 1 over 4, because this power will multiply this. Remember that the power is minus half. It is multiplying minus half. Minus times minus is plus. 1 times 1 is 1 over 4. 2 times 2 is 4. So we have this. Then t raised to power minus half minus 1, because you must subtract 1 from the power. It will now give us minus 3 over what? 2. So that's what we got there. So now at this point, we are going to find our acceleration at an instant, that is at a point when t is what? 2 seconds. So acceleration, the s dt squared, at the instant when t is equal to 2 seconds. This will now be equal to, we come to this function, any place we see t, we replace it with 2. So this is 24 into 2 raised to power 2 plus 6 into 2 plus 1 over 4 into, this is our t. Our t is what? 2 raised to power minus 3 over what? 2. Okay, if I simplify this, this is 24 into 2 raised to power 2 will give us 4. Then 6 times 2 will give us 12 plus 1 over 4 into, so 2 raised to power minus 3 over 2 means 1 over 2 raised to power 3 over what? 2. Okay, that's what this means. Okay, so here 24 times 4 will give us 96 plus 12 plus, so this is 2 raised to power 3 over 2. So 2 raised to power 3 over 2, I can write it as 2 raised to power 3, everything raised to power 1 over what? 2. In such a way that 2 raised to power 3 will give us 8 raised to power 1 over 2, which is equal to sod what? 8. And sod 8 will give us what? 2 sod 2. Okay, sod 8 is 2 sod 2. So you can still take everything and press it to your calculator. You find out that it will give you 1 over 2 sod 2. You can press everything in your calculator, like you say 1 over bracket open 2 bracket close raised to power 3 over 2. Find out that it will give you 1 over 2 sod 2, which will give you 0.3535 continuous. Okay, that's what you get there. So on that note, what I have here is 1 over 4 into 1 over 2 sod 2. So if I should expand this, I have 96 plus 12 plus, this times this will give us 1 over 8 sod 2. So when if I should add everything together, 96 plus 12 plus 1 over 8 sod 2. So this will be giving me 108.088 meter per second squared. Okay, So that's what I got. If you add everything up, this is what you're going to get. Don't forget what we did. A car is given by this. This is the position, this is the displacement or the distance equation. So they say we should obtain instantaneous acceleration. So what do I have to do? Since I have my position, I know that if I differentiate distance with respect to time, I will get velocity. Had it been that they are asking about instantaneous velocity, this is where I will take my instantaneous velocity at t equals to what? 2. But they are asking of instantaneous acceleration. So once I get velocity, I differentiate it again. I will now get what? Acceleration. So once I get my acceleration, I'm going to take my value when t is what? 2 seconds. That's all. So assuming, let's say, let me bring in another question. Assuming they said that let's say they give us equation of velocity, because there are times they will give you equation of velocity to be 2t plus, let's say, 5t squared. Let's assume that they give us equation of velocity and they say we should find what? Instantaneous acceleration. Now, since you have velocity, you know that when you differentiate velocity, immediately you get what? Acceleration, because acceleration is change in velocity with respect to change in time. So just differentiate this. The power here is 1. 1 times 2 is 2. Then 1 minus 1 is 0. Any to the power 0 is 1. Then plus 2 times 5 is 10. Then we remove 1 from this 2. It will remain just t raised to power 1. So as you can see now, this one I just differentiated once, because this is equation of what? Velocity. Okay, so when it is velocity, just differentiate with respect to time, you get your what? Acceleration, because acceleration is change in velocity with respect to time. So you need to be checking this. Like this one is equation of what? Displacement or equation of distance. So first of all, you differentiate it and get what? Velocity. Because when you differentiate distance, you get velocity. Don't forget, velocity is the rate of change of displacement with respect to what? Time. So when you differentiate displacement, you now with respect to time, you get velocity. Then when you differentiate velocity with respect to time, you now get what? Acceleration. So as you can see, this is our velocity. We now differentiated it, we now get what? Acceleration. A time shall come also when they will give you only velocity. When they give you velocity, just differentiate it immediately and now get what? Acceleration. Then you now take it at that given time given. Okay.